So what we're going to do here, is try to rewrite this so that it's not a fraction composed of fractions. This is a complex fraction, and we want to write it as just a simple fraction. And we're going to do that by finding the overall LCD. So look at what we have. 1, 2, 3, 4 terms. The overall LCD is, in this case, just x. So the LCD here is x. And then, now I'm going to do this one step by step here. So what we're going to do is we're going to take the original and we're going to multiply this by 1. But the one that we're going to choose is going to be the LCD over the LCD. So instead of writing 1, I'm going to write x over x. So rewriting this now, it will look like this. 3 plus 6 over x, 2 minus 5 over x times 1, but I'll write it as x over x. And then what we've got is multiplication of fractions. Now I'm going to multiply the tops together and multiply the bottoms together. So let's indicate that. Let's take that entire left top, 3 plus 6 over x, and we'll multiply that by x. And same thing in the denominator, that 2 minus 5 over x times x. And then we will use the distributive property and distribute that x all the way through. I'll do that up here at the top, right up here at the top. And that will give us 3x plus x times 6 over x over 2x plus minus, right, minus, let's do it right here, minus x times 5 over x. Now, let's just stop for a minute and see what we did here. See that back at the beginning, that LCD? We did all this work, and where did it end up? That LCD ended up right next to this 3, right next to this term, right next to this term, and right next to this term. So from now on, from this problem on, I'm just going to write the LCD, and I encourage you to just do this. Write the LCD right next to all the originals. Right, so I'm going to write it, here it is next to the 3, here it is next to this one, here it is next to this one, here it is next to this one. That'll save us all this work, and we know it will always be true. So let's see where this takes us now. Right here, we're going to get 3x, so we'll just get our 3x plus, but then what happens here? These x's are going to cancel. So if we just cancel those x's, I'll do it right here, we're just left with that 6 over 2x minus, and again, these x's are going to cancel, so let's cancel those, and we're left with that minus 5. So I'll write that as minus 5. So it looks like we're left with 3x plus 6 over 2x minus 5, and we could do this. You can see you can factor a 3 out of the top. If we wanted to do that, we can. It's not going to go anywhere because we can't factor anything out of that denominator. So let's just conclude that we are done. So we're taking this set of computing instructions, rewriting them into this more efficient form right here. So in sum number 17 here, we're going to try to find 1, 2, 3, 1, 2, 3. I got 6 terms here. The LCD of all of these is, do you see it? There's a 1, an x, and an x squared. A 1, an x, and an x squared. The overall LCD here is the x squared. And then we are going to write that x squared next to every one of the originals. We're going to put it here, 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 and here. Let's do it. So we'll get 1 with the x squared minus, let's put the x squared here in the middle next to the 3 over x, and then minus the x squared next to that 28 over x squared. Let's go to the denominator and put the x squared next to each one of those terms. 1 times the x squared minus the x squared next to the 10 over x plus the x squared next to the 21 over x squared. And now, simplifying in the top, the numerator, we're going to have 1 times x squared is x squared, so let's take care of that. We'll get x squared minus, now, there's 1 x in the bottom, 2 in the top, so That x in the denominator will cancel with one of these in the top. Let's do it. That x cancels with that one, and we are left with minus 3x. Right, minus 3 and the x. So let's write our minus 3x. And then minus, now this x squared in the denominator cancels with that x squared, so we're going to cancel those. That goes with that, and then we are left with minus 28. So we'll write our minus 28 over, okay, x squared minus, and then what happens here, that x will cancel with one of those. So let's do that. That one cancels with one of those, and we're left with 10x. So we're left with a minus 10x, and then what about here? That's going to be a plus, and then this x squared cancels with that one, and we're left with plus 21. Let's see what we get here now when we factor. So how about x and x? I'm thinking, for that 28, I'm thinking a 7 and a 4. 7 and a 4. And the 7 is going to be the negative 7x plus 4x is negative 3x right there. All over, let's see where we are. I need an x and an x. And for that 21, I'm thinking a 7 and a 3. So let's write the 7 and the 3. The 21 is positive. These are going to have the same sign, which is going to be that middle minus sign. So we'll put a minus 7 minus 3. Going to get some cancellation there, right? So let's cancel those. So we'll cancel the x minus 7 with x minus 7. And then we are left with x plus 4 over x minus 3. So we're going to be left with x plus 4 over x minus 3. And this is all going to work as long as x is not equal to, right, follow it right back up. You can't use a 7. You can't use a 3. But also, right back from the very beginning, right back from the very beginning, look what we had. We got a denominator here of x. The LCD is x squared. So x, because it appears in the denominator by itself, we can't use a 0 here. So these three numbers have to be excluded. And if we exclude those, then we're saying that this set of computing instructions can be replaced with this much more compact, more efficient set of instructions. We have 1, 2, 3, 4 terms, and the overall LCD, we've got an x plus 2 and an x minus 2, and then they're repeated down here. So the overall LCD here is going to be x plus 2, x minus 2. Now, we've done this a few times, so we know what to do. We're going to take this LCD and we're going to write it next to every original term. So look what we're going to do. X plus 2x minus 2, we're going to put it here. Then we're going to put it here. Then we're going to put it here. And then we're going to put it here. And then all those denominators will cancel. So it's a little bit long to write, but let's do it. So let's start by writing this LCD right here and right here. That is going to give us, okay, x plus 2, x minus 2 dot 1 over x plus 2. So I took the LCD here and I wrote it right here, right next to this x plus 2. So there it is. Now plus, all right, let's put it again, x plus 2, x minus 2 dot 1 over the x minus 2. So I've got it right here. There it is. All over. Almost going to look the same here. X plus 2, x minus 2 times. But now what we're doing is we're taking this LCD and putting it right here. So 1 over x minus 2. And then minus. Right, there's that minus sign right there. Minus x plus 2, x minus 2 dot. Now we're putting it right here next to the 1 over x plus 2. So 1 over x plus 2. And now all these denominators should cancel here. Let's see what we have. This x plus 2 is going to cancel with that one. So let's do that. That cancels with that one. Over here now, This x minus 2 is going to cancel with that x minus 2, so those will cancel. And down in the denominator, this x minus 2 cancels with that one, so those go out. And then, in the bottom right, this x plus 2 is going to cancel with that one. Let's do that. So here's what we are left with. So we are going to have x minus 2 plus, and then multiplying here, we'll get x plus 2 over, now down here we'll get x plus 2. And now be careful here, this is a minus, so minus x plus 2, right? Minus x minus 1 times minus 2 plus 2. So minus x plus 2. Now what are we going to get here in the top? X plus x is 2x, minus 2 plus 2, that's going to go out. I'm going to do this way up here at the top here. So we're going to get x plus x is 2x, minus 2 plus 2 goes out. So we're left with x plus x is 2x over, now what about the denominator? X minus x, that's gone, 0. 2 plus 2 is a 4, so we're going to get no x's, but we'll get a plus 4. So we'll get a 4 here. And then finally, we can cancel, right? 2 will go into 2 once, 2 will go into 4 twice. So we are left with x over 2. Now that's pretty nice. So this says that this original set of computing instructions, which looks pretty complicated, can be reduced to this very compact, efficient set as long as, right, go back to our LCD, what can x not be? Negative 2 or positive 2? So back here, we're going to say that this works as long as x is not equal to negative 2 and positive 2. So this original set of computing instructions is replaced by this set, much more compact and efficient, as long as we don't use negative 2 and 2.